Hello, good afternoon. My name is Ashraf Badawi. Uh, the team is part of the Wade City of Science and Technology in Egypt. Our presentation today is titled Balancing the Role of Machine Learning and Teacher in the Adaptive Learning Guidance Systems that we are trying to build at Wade City. Thanks for giving us the opportunity to present our work to this great audience. We wish to have been with you in person, but hopefully we'll get the chance sometime in the future. So one of the questions that was asked prominently is how do we balance the role of the teacher versus the machine learning? They apparently are not speaking the same language. The multiple dimensions and multiple parameters that can be readily assessed and put into context and put into use by a machine learning algorithm would make the teacher not able to follow up what the recommendations and why are these recommendations being made. And we would like to suggest that how can this balance be achieved? So we start by the problem statement. What are the two main components of the ALGS? Why is the teacher role crucial in adaptive learning systems? Why is the collaborative nature of the environment important? And where do we see the best contribution of the machine learning? And now go back to the role of the teacher. How do we maintain an active role, a central role for the teacher and mentor in the adaptive learning process? So the problem statement is the adaptive learning environment can have different flavors. Some are intelligent tutoring systems, some are learning analytics. Some assume that it's a one-on-one, some assume that there is a classroom environment. And relying solely on deep learning came with concerns about how do we include motivation, procrastination, engagement, and other items that might not be present, might not be readily available for machine learning to assess. What is the motivation for me to do this? Where do I see myself heading? A lot of stuff, a lot of dimensions that the teacher can add to the process that might be not easy for a machine learning algorithm to include at all. Artificial intelligence can perform tasks beyond human capabilities, obviously, which may result in a level of complexity in the system that would generate adaptation that the teacher might not be able to interpret readily, and might actually be counterintuitive for in instances where the teacher knows something about this or that student that might not agree on this is the best step to overcome this hurdle for the student. The novelty of the ALGS is proposing how does this balance could be, and this is definitely under development, how this balance can be achieved. How do we balance the strengths that's brought on by the machine learning and the human factors in an attempt to reduce this gap or apparent gap between mixing the role of the machine learning and the teacher? So the two main parts is that the ALGS is based on the teacher and the computer-supported collaborative environment, and the human guidance and computer-supported collaborative learning are both suggested to work side by side. So the system hopefully will merge the strengths of both domains in a sense of collaborative filtering or adaptive guidance system, not a totally adaptive system. So the adaptive guidance system has the teacher, which has a specific content model So the teacher has an experience with this content, has a good understanding of how this content can serve the learning objectives for and the learning plan and the learning path for each one of these individuals, what decisions need to be made, and how the recommendations can be reviewed periodically in order to modify the path in order to achieve or overcome hurdles. On the other side, CSCL can have different elements, which is facilitating group work, making individual tasks, having discussion forums, a whole bunch of elements and affordances that can be quite useful for the students to advance down the learning path. How do we merge the strengths of both into this adaptive learning guidance system? So the machine learning that would measure what the environment can tell us about the students versus what the teacher know, and how can the teacher's experience benefit this process. So why is the teacher role crucial in the adaptive learning system? Adaptive learning system deploys the mentor's physical existence with technology to maintain a healthy learning environment that corresponds to the individual's learning needs. So basically, this could be in a classroom environment, in a one-to-one settings, offline, online, depending on what's the teacher file, what's the learning the profile for the learner that the teacher maintains can tell us about that learner. What motivates him or her, what sort of procrastination, is she engaged, not engaged, is she keeping a cohesive learning environment online, what can be enhanced in this interaction, how can this interaction work to the benefit of the learner. That's obviously something that cannot be obtained without a human overseeing this process. Just to assume that the environment and the sort of one-to-one interaction with the material that a learner can have within the session can simply give us what since I can measure that, since I can measure this particular action, or I can measure this particular response, then I know the mental process that is accompanying it. There is a lot that can go that would change that picture in terms of, is the student engaged or not engaged in an online session? Is it did the student open the assignment as soon as he got it? Did he start? When did actually they went online and accessed the material and looked at the videos? Were they skipping through the video? Were they motivated? All of this stuff that can be measured but can only put into context with what we know about the student through the teacher, him or herself. So why is the environment itself? The environment gives affordances to facilitate group interactions, whether in the same place, same time, different place, different time. All the different modes of interaction can only be supported by good environment, enabling the learner to exchange ideas and help each other to understand the topic and answer the questions in a collaborative way. This is the environment can have affordances that would make that interaction a lot more rich, and can have enable both synchronous and asynchronous modes, and can have positive effects that goes way beyond a classroom environment, which is definitely this setting, which is same time, same place, can definitely be part of the modes that can be facilitated by the CSCL. So if we have the role of the teacher on one side versus the role of the machine learning on the other side. Teacher can be creating the database upon which the system filtering function is based. So we have a whole bunch of content, we have a whole bunch of attributes that the collaborative filtering can work based upon, feeding the system with the data about the learners and the results of the face-to-face interaction in the classroom and outside it, suggesting an initial path. If there is no data, then there is no data for the machine learning to work upon, and having this individual model. So even if we have a model for the content, we don't have a model for the learner, and how these two will interact with each other. So the initial path is definitely the job of the teacher. So we can have a pre-assessment and then an initial path that is set by the teacher, receiving a system alarm that tracking the history of a particular student if they are exhibiting behavior that is totally outside. So even if we're talking about many students taking the course at the same time, if some of them are their behavior and their interaction with their peers and with their with the material is totally outside, so this can bring up an alarm to the teacher, reviewing and refining the system generated recommendations, keeping on top of the learning process, and intervening and taking proper action either in the class or feeding the adaptive decision to the system. So all of this can be the role of the teacher. On the other hand, the role of the machine learning is building a reliable user model. So this user model with its multiple attributes is the key in the adaptation process, collecting data about the student's action, behavior, all what we can measure about them, of course within all the constraints about what we can and cannot measure, what we cannot give consent towards recording, detecting any deviation from the behavior of the learner from the peer group. So this is something that if somebody is doing something that is way outside their peer group, then this is an alert for the teacher to come and see if there is something happening here, if somebody that is skipping too much into this video, is there something about the video or about the learner, what is it that needs to attract the teacher attention to what's happening with that particular situation. Generating automated recommendations, obviously, but then this is an input to the teacher. So it's only if the teacher gives the option that this would go directly to the student, that this will go unchecked directly to the learner, or if there is high confidence from the system that what we are measuring about the student is not very much different from their peer group and not different from the expectations on the learning path, then this typical cases can just simply progress with their own individual pace through the recommendation path. And processing highly time-consuming analysis, of course, as per what we expect from the machine learning, tailoring the adaptive recommendations based on the user model which has input from the teacher. So basically what we envision this working is we create the content models, what the student should be learning. So we have learning objectives, we have skills, we have this entire matrix that we normally build for the learning path, and then what the student should be learning and what content could fill out this interaction matrix. And then we build the user metrics by psychometrics, by collaborative filter, by peer assessment, whatever we can build about the user beforehand. So we have a user model that is initial. So we have initial content model and initial user model that we can have pre-assessment and psychometrics that we can measure about the student. And then we start adding recommendations. So, okay, so for that particular student in this particular situation, given what we know about them, then this is the path that we recommend. And then we can now make learning decisions. What we can measure about the students during the session, after the session, while interacting with the material, online, offline, what time did they start how much time did they take, what sort of difficulties. This would have this adaptive component, in the sense of, okay, so this information for the teacher can either choose to pass this information as it is, or can modify it based on what they know. Once we add elements that can measure the engagement of the students during the session, then this is actually more ears and eyes to the teacher to sort of know whether there is a learning difficulty here, or simply the students were not paying attention during the session. This is our references, and once more, we are grateful for this opportunity. This work is still under development. We are glad to take any questions from the audience. Thanks, and have a good afternoon.